Wabarakatuh. Today, inshallah, we're going to solve practice questions on conservation of mechanical energy. Okay, the first question we have, starting from rest, a child zooms down a frictionless slide from an initial height of 3 meters. What is her speed at the bottom of the slide? Assume she has a mass of 25 kilograms. On the conservation of energy, mechanical energy initial equals mechanical energy final. Mechanical energy initial have two types of mechanical energy, either kinetic energy or potential energy. Potential energy, I have gravitational potential energy and elastic potential energy. So kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. Most of the questions, they will ask you about find the height, find the velocity, okay? Now, plus I'm going to add here energy lost due to friction, plus energy lost due to friction. And if I have work, if I have force applied to the girls, I'm going to add it. But since there is no work and there is no energy loss, so we cancel these, 0. At the beginning, this is the initially. Initially, the girl was at height h before she slid down the sled. So the initial energy she has is gravitational potential energy. The girl wasn't moving when she was here at the top. So the kinetic energy, 0. So the type of energy is gravitational potential energy initial equals. Now when the girl starts sliding down, just before it reached the floor, the energy she has, since we don't have height here, okay, this is the final, it will be only kinetic energy. So kinetic energy final, there is no height, that means potential energy here is 0, we don't have it. Now, gravitational potential energy is m mass times full acceleration times height, mgh, equals half m v squared, v final squared. Now, we're talking about the girl, same girl she has the same mass, so m and m, they can cancel out. G, free-fall acceleration, we'll take it 10. Height, the initial height is 3, this is h, so 3 equals half v final squared. I'm going to do cross multiplication. So v final squared will equal 10 times 3 is 13 times 2, and this will be 60. To get rid of the square, we'll take square root for both sides. So I'm going to take square root for both sides. The square root and square they cancel out. So v final will equal 7.7 meter per second. Meter per second. Okay, we'll solve one more question. Okay, you have a mass. You have 1.25 mass connected to a spring. Okay, and it has a spring constant, so m, this is the mass, 1.25 kilograms. The mass is connected to a spring. So we have a spring here and mass connected to a spring. Has a spring constant here, 25 Newton per meter. This is the spring constant. Displaced 4 meters. So delta x 4 meters before being released. So we just stretch the spring and it displaced here 4 meters. before being released, find the maximum velocity of the mass during one cycle. I need V. Okay, and most of the conservation of energy problems, they will ask you find the height, find displacement, find the velocity. Okay, now I'm going to use also the conservation of energy again. Mechanical energy initial equals mechanical energy final. Okay, since we stretch the spring, we stored elastic potential energy. So the energy initial is elastic potential energy. Let's try the formula first. So kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. At the beginning, the spring is not moving, so this will be 0. I have a potential energy, and it is elastic potential energy. I stored it in the spring when I stretch this mass. So it will be elastic potential energy initial equals spring start to move. So I will have kinetic energy final. There is no potential energy. Elastic potential energy, it's half K delta X square equals half M V square. Okay, M and M we can cancel out. K is the spring constant. K will be 25. Delta X, the displacement, is 4 meters square equals the mass of the block is 1.25 times V square. I need V square to be alone by itself because I need to find the value of V square. So I'm going to divide both sides by 1.25 by 1.25. And then take square root for both sides. So V will equal square root 25 times 4 square divided by 1.25. And it will give us 17.9 meters per second. Okay. Let's solve another one. This is also for elastic potential energy. Here we have a spring of a jack in a box. Is compressed a distance 8 centimeters from its released length. So let's try the conservation of energy. First, kinetic energy initial. Yeah. I'm going to write the given, sorry. We'll write the given first. I have compressed a distance. So delta X, 8 centimeters converted to meter, it will be 0.08 meter. And then released. What is the speed of the toy head when the spring returns to its natural length? So I need the velocity. Assume the mass of the toy head is 50 grams. So M, 50 divided by 1,000 will be 0.05 kilogram. And the spring constant here, the spring constant is 80 Newton per meter. Okay, and the toy head moves only in a vertical direction. So it will move up in a vertical direction to be the same as the displacement, which is 0.08 meter. Okay, so let's try the formula now. Conservation of momentum, kinetic energy initial plus potential energy initial. We don't have work, we don't have energy lost. So we'll ignore work and energy lost. This will equal kinetic energy final plus potential energy final. Now, at the beginning, the spring of jack in a box in compressed. Compressed, I have a compression and I have a spring. So it will be elastic potential energy. So I have a potential energy and the type of potential energy is elastic potential energy initial. There is no kinetic energy. Now, what will happen? Jack in a box starts moving up, and it moves up certain distance h, certain height h. So I have kinetic energy final, and I have potential energy as well. And this type of potential energy will be gravitational potential energy. So I have a kinetic energy final plus gravitational potential energy final. Now let's substitute. This will be half K delta x squared equals half m v final square plus mgh for the potential, for gravitational potential energy. Now plug these values. Okay. So to be half solution, half spring constant is 80, delta x is 0.08 squared equals half. The mass of the head of this toy is 0.05 times v squared, we don't have it, v final square, plus mgh, m is 0.05, g is 10, and h is 0.08. Okay, now we're going to use the calculator. Now we'll calculate these values. So I have half times 8 times 0.08 squared. Okay. This will equal 0.256 equal 0.05 divided by 2. It's 0.025 v final square plus 0.05 times 10 times 0.08 plus 0.04. Now we'll keep the numbers alone in one side and the variable on the other side. So I will take this number to the other side. Here I have positive, so when it goes here, it will become negative 0.04. I'll remove it from here. So 0.256 minus 0.04. Okay, this will give us 0.216 equals 0.025 v final square. Now I'm going to get rid of 0.025, divide both sides by 0.025, 0.025, and take square root to get rid of the square. So I'm going to take square root for both sides at the same time. So we have here v final will equal, let's do this one on the calculator. It will be 2.93 meter per second. Meter per second. Okay. Another more example. Here we have an Olympic runner leaps over a hurdle. If the runner's initial velocity, so the initial velocity, the initial, is 2.2 meter per second, how much will the runner's center of mass be raised during the jump? So I need to find the height, h. How much? These are the givens. Now we're going to solve the question. Again, the conservation of energy. They will ask you most of the time, find the velocity, find height, find the displacement if you have a spring. So kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. Now at the beginning, she's running. That means she has kinetic energy. The type of energy is kinetic energy. When she was running, at the beginning, she doesn't have any potential energy, no height, no spring, no anything that's being stretched, so no potential energy. So initially, it's only kinetic energy. Okay, now after that, she jumped over this hurdle. So jumped, that means we have height. So it will be kinetic energy if I want to find the maximum height. Always when you have maximum kinetic energy, potential energy will be 0. If you have maximum potential energy, kinetic energy is 0. So maximum height, that means the kinetic energy 0, and I will have gravitational potential energy final. Now substitute. So this will be half m v initial square equals mgh. Same moments, same mass, so m and m they cancel out. So half v initial is 2.2 square equals g is 10, and I need h. So divide both sides by 10 to get rid of 10. And if you plug these values in the calculator, h equals half times 2.2 square divided by 10 will give us 0.24 meter. 0.24. Okay, one more example. Here you have a pendulum bob is released from some initial height. So the initial energy here, it's gravitational potential energy, and it will be maximum. Maximum gravitational potential energy, kinetic energy is 0. Okay, now when it's released, the speed of the bob at the bottom of the spring, here at the bottom of the spring, I don't have height, so the type of energy is only kinetic energy final, potential energy 0. So I'm going to use the conservation of energy. Gravitational potential energy initial equals kinetic energy final. mgh equals half mv squared, m and n cancel out. G it's 10. H we don't have it, we need it. Equals half. V final is 1.9 squared. Divide both sides by 10. Find the value of h, so divide by 10, divide by 10. H will equal 0.18. Okay, we'll do another example, another question. Here we have a question 6. Question 6, you have a bird. The bird is flying with a speed, so the bird is flying with velocity 18 meters per second over the water when it accidentally dropped 2 kilogram fish. So the speed of the bird, and it's the same time at the speed of the fish, because the bird is holding a fish in his mouth. That means both of them are moving with the same velocity, which is 18 meters per second. The mass of this fish is 2 kilograms. If the altitude, the height of the bird and the fish, so h, this height is 5.4 meter, 5.4 meter. There is no friction, so ignore the friction. What is the speed of the fish when it hits the water? So I need the velocity of the fish, V final of the fish when it hits the water. These are the given. Now, I'm going to use the conservation of energy, kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. At the beginning, the fish and the bird were moving, so I have a kinetic energy, and there is height if we take our reference here, the gravitational potential energy at the surface of water is 0. So there is height. So I have a gravitational potential energy. So I have a kinetic energy plus gravitational potential energy initial equals. Now, when the bird drop the fish here, I don't have gravitational potential energy, so gravitational potential energy is 0 at the surface. But the fish is moving at the when gravitational potential energy is 0, I have maximum kinetic energy. So the kinetic energy finally will be maximum at the surface, just before it hits the surface of water. Now, kinetic energy, it's half m v initial square plus mgh equals half m v final square. Okay, m cancel out. Now substitute with the values we have. So it will be half v initial is 15 square plus g is 10. The height is 5.4 equals half v final. V final square. Okay, so we calculate these values. Just put them in the calculator. I have half times 18 square plus 10 times 5.4. This will be 216 equals half v final square. Now the cross multiplication will be 216 times 2 equals v final square. I need v final without the square root. So we'll take square root for both sides. Okay, so times 2 under the square root will be 20.7 v final. V final will be 20.7 meter per second. Meter per second. Okay, now the last question I'm going to solve is this one. Okay, here we have 755 in Newton diver. Newton, it's a unit of force. So this is the weight of this man, the weight of the diver, this man standing here on the board. So his weight, Fg, equals 755 Newton. Drops from board 10 meters above the board, the water surface. So the height of the board here, this one is 10 meters above the surface, the water surface. If we take the water surface here, where gravitational potential, this is our reference, 0. So anything on the top should be, the potential energy is positive. Okay, now let's continue. We see the rest of the question. And here we have, find the diver's speed 5 meters above the water surface. 5 meters above the water surface. So it's not here. So I'm not going to take this one. Yeah. Yeah. 5 meters means at the middle. Here. 5 meters. Okay. So here, this is my reference. Okay, about 5 meters above the water surface, and then just before it hits the water. Okay.
all multiplied by 1 The question already did it wrong. All is how much?
طيب. So find the diver speed 5 meter above the water surface, which is what? 10 meter. So the diver is here. Here now. Here. Here. Here 5, and also here it will be what? 5 meter. I'm going to take this one, the gravitational potential energy here is 0. So the conservation of energy, kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. Now, at the beginning, here is the initial position. When the diver is standing on the board, he has height 10 meters from the surface of water. So it's that type of energy is gravitational potential energy. And since he's not moving, so he doesn't have kinetic energy. So no kinetic energy. It's only gravitational potential energy initial equals. At this position, this is the final position. At this position, the diver has height, which is 5 meters above the surface of water, and he's moving. So he has kinetic energy final and gravitational potential energy. So kinetic energy final plus gravitational potential energy final. So let's substitute now. Here, M, G, I'm going to call this one H1. And this height here, we call it H2. So the height of a diver from the surface of water, H2, 5 meters, equals half M V squared plus mg H2. M cancel out. G 10. The first height 10 equals half. The velocity of the diver, we don't have it, V final square plus G is 10, H2 is 5. So 10 and 10, 10 times 10 is 100. 100. This is 15. Take it to the other side, it will be minus 15 equals half. V final square, and then do cross multiplication. So to be 50 times 2, 100 equals V final square, take square root for both sides. So we will have V final equals square root of 100 equals to 10 meter per second. 10 meter per second. Okay. Now next, find the diver's speed just before striking the water. Just before striking the water. Okay. Okay. Standing here, and the height at the surface of water, the gravitational potential energy is 0. So anything on the top, it will be positive. So the height here is positive 10 meters, and he's standing here. So the initial energy here will be gravitational potential energy. Initial equals, when it just before it hits the surface of water, we don't have a gravitational potential energy because there is no height. But the kinetic energy will be maximum. So here at this position, just before it hits the water, you will have kinetic energy final. So here, mgh equals half m v squared, m and m cancel, and then substitute. 10 times 10 equals half v final square cross multiplication, and then take square root. So v final will be square root of 200. Okay, and this will equal 14.1 meter per second. Okay. Now the last section. Let me just erase these, and then we'll do the last section. Okay, see now. Here, if the diver leaves the board with initial upward speed, so the diver will jump up with initial speed 2 meters per second. Find the diver's speed just when striking the water. So he will jump up and then he will fall back again, to reach the surface of water. Okay, so the initial he has here, since he's moving, jumping up, and there is height, which is 10 meters. The initial energy is kinetic, but there is movement, there is speed, and gravitational potential energy. Just before he hits the surface of water, we don't have height, so we only have kinetic energy final. So this will equal kinetic energy final. So here we have half m v initial squared plus mgh equals half m v final squared, m cancel out, and then substitute. So half v initial is 2 squared plus g is 10, h is 10 equals half v final squared. Now do cross multiplication. Find first the answer and do cross multiplication. 4 squared divided by 2 is 2. Okay. 2 plus 100, 102 times 2, 204 under the square root. Yeah. So this will be 204 equals v final squared. Take square root for both sides. So v final, the square root of 204 is 13.3 meter per second. Okay, that's it. Next video, inshallah, will be about power.